Imagine a time before time existed, a time so distant and so foreign that it defies our very understanding of reality, a time before light, before matter, before even the vast emptiness of space, a time when there was nothing and yet everything was about to begin. Then, 13.8 billion years ago, from a point of unimaginable density and heat, the universe exploded into existence. This singular event marked the birth of everything we know. We call this event the Big Bang. It was the moment when the universe began its grand journey of expansion and evolution. It wasn't an explosion in the traditional sense, like a firework in the night sky. Instead, it was a rapid expansion of space itself, a stretching of the very fabric of reality. This expansion carried with it a sea of energy, a primordial soup that would eventually give rise to everything we know, from the smallest particles to the largest galaxies. In the first fleeting fractions of a second, the universe was an inferno of energy. Temperatures soared to unimaginable heights, and the forces of nature as we know them were born. As this energy cooled, it began to condense into particles, the building blocks of matter. These particles at first were a chaotic soup, constantly colliding and annihilating each other. These particles at first were a chaotic soup, constantly colliding and annihilating each other. It was a time of great turmoil and transformation, yet from this cosmic dance a crucial imbalance emerged. For every billion particles of antimatter, there were 1,000,001 particles of matter. This tiny excess, a mere whisper in the cosmic symphony, was all that was needed to set the stage for the universe we see today. It was this imbalance that allowed matter to dominate and form the structures we observe. This tiny excess, a mere whisper in the cosmic symphony, was all that was needed to set the stage for the universe we see today. It was this imbalance that allowed matter to dominate and form the structures we observe. The Big Bang wasn't just the start of the universe, it was the start of time itself. It marked the beginning of a cosmic clock that has been ticking ever since. Every moment, every event, every story that has ever unfolded can be traced back to this singular, awe-inspiring event. From the formation of the first atoms to the birth of stars and galaxies, it all began with the Big Bang. It's a humbling thought to realize that we are all, in a very real sense, children of the Big Bang. Every atom in our bodies was forged in the crucible of this cosmic event. As the universe continued to expand and cool, the stage was set for the next chapter in our cosmic story, the formation of stars and galaxies, the building blocks of our vast and magnificent universe, the building blocks of our vast and magnificent universe. And so the story of the cosmos began, a tale of creation and transformation that continues to unfold to this very day. From the chaos of the early universe, a new order began to emerge. The universe, once a hot, dense soup of particles, started to cool and expand, setting the stage for the formation of the first structures. Gravity, the invisible sculptor of the cosmos, began to draw together the scattered remnants of the Big Bang vast clouds of hydrogen and helium gas. These primordial elements, the building blocks of the universe, were pulled together by the relentless force of gravity. These clouds, drawn together by their own mutual attraction, began to collapse in on themselves. As they did, they started to form denser regions, the seeds of future stars and galaxies. As they contracted, they spun faster and faster, like a skater pulling their arms in tight. This rotation caused the clouds to flatten into disks, where the central regions grew increasingly hot and dense. The immense pressure at the heart of these collapsing clouds ignited a new kind of fire, nuclear fusion. This process, where hydrogen atoms are fused together to form helium, releases an enormous amount of energy. Hydrogen atoms, crushed together under unimaginable force, fuse to form helium, releasing a torrent of energy in the process. This energy, in the form of light and heat, marked the birth of the first stars. This energy, radiating outward, pushed back against the collapsing cloud, creating a delicate balance, the birth of a star. These newborn stars began to shine, illuminating the darkness of the early universe. The first stars were giants, far larger and hotter than our own sun. These massive stars burned their fuel quickly, living short but brilliant lives. They blazed brightly, illuminating the early universe with their intense light. Their radiation began to ionize the surrounding gas, making the universe more transparent to light. But these stellar pioneers lived short, violent lives, eventually exploding as supernovas, scattering the elements they had forged in their fiery cores far out into space. These supernova explosions were among the most energetic events in the universe. These scattered elements, the ashes of dead stars, would become the seeds of future generations of stars and planets. The heavy elements created in these explosions were essential for the formation of planets and life as we know it. Over eons, gravity continued its work, drawing together stars into vast swirling collections, galaxies. These galaxies, each containing billions of stars, became the fundamental building blocks of the universe. These islands of light, containing billions upon billions of stars, spread out across the expanding universe, each a testament to the power of gravity and the relentless cycle of cosmic birth, death, and rebirth. The formation of galaxies marked a new era in the history of the universe. Among these countless galaxies, our own Milky Way began to take shape, a spiral of stars and gas, a cosmic cradle for our solar system and our planet Earth. The Milky Way, with its billions of stars, became the home of our solar system, where the story of life would eventually unfold. Within the vastness of the Milky Way galaxy, a place teeming with countless stars and cosmic wonders, about 4.6 billion years ago, an extraordinary event began to unfold. A remarkable event took place, one that would set the stage for the birth of our solar system. A giant cloud of gas and dust, remnants of long-dead stars, began to collapse under its own gravity. This cloud, known as the solar nebula, was a swirling mass of cosmic material. We call this cloud the solar nebula, and it was from this swirling chaos that our solar system, including our own planet Earth, would eventually emerge. The process was slow and gradual, taking millions of years. As the solar nebula contracted, it began to spin faster and faster, like a figure skater pulling their arms in tight. This increase in rotational speed caused the cloud to flatten into a disk shape. This spinning motion flattened the cloud into a disk, with most of the material concentrated at the center. The outer regions of the disk were cooler, while the center became increasingly hot and dense. At the heart of this swirling disk, the temperature and pressure soared, eventually reaching a point where nuclear fusion ignited. This fusion process marked the birth of a new star. A star was born, our sun. The sun's formation was a pivotal moment, providing the necessary heat and light for the development of the solar system. The sun's birth marked a turning point in the evolution of our solar system. Its intense heat and radiation began to shape the surrounding disk of gas and dust. Its intense heat and radiation pushed outward, driving away the lighter elements like hydrogen and helium from the inner regions of the disk. This process left behind a ring of heavier elements. Rocks, metals, and ices, the building blocks of planets. These materials began to coalesce, forming the early building blocks of our solar system. Within this disk, dust grains, drawn together by electrostatic forces, began to clump together, forming larger and larger aggregates. These small clumps grew over time, colliding and sticking together. These aggregates, in turn, collided and stuck together, gradually growing into larger bodies called planetesimals. These planetesimals were the seeds of future planets. These planetesimals, drawn together by their own gravity, continued to accrete material, eventually forming the planets we know today. Over millions of years, these bodies grew larger and more complex. Thus, from a chaotic cloud of gas and dust, our solar system, a family of planets orbiting a central star, was born. This intricate dance of cosmic forces gave rise to the diverse and dynamic system we are a part of today. In the swirling chaos of the early solar system, our planet Earth began to take shape. Billions of years ago, within the protoplanetary disk surrounding the young sun, countless planetesimals, remnants of the solar nebula, orbited and collided. These collisions, driven by gravity, gradually built up larger and larger bodies. Over millions of years, these collisions continued, with some planetesimals growing larger, sweeping up their smaller neighbors. Among these growing protoplanets was the young Earth, its size and gravitational pull increasing with each impact. The early Earth was a hot and violent place. Constant bombardment by asteroids and comets released tremendous amounts of heat, melting the planet's surface and creating a magma ocean. As Earth grew larger, its gravity became strong enough to hold on to a thin atmosphere, mostly composed of gases released from the planet's interior through volcanic eruptions. This early atmosphere was very different from the one we breathe today, lacking free oxygen and rich in greenhouse gases like carbon dioxide and water vapor. Gradually, over millions of years, the bombardment from space began to subside. As Earth cooled, the magma ocean solidified, forming the planet's first crust. Water vapor in the atmosphere condensed, falling as torrential rain and forming the first oceans. The stage was set for the next chapter in Earth's story, the emergence of life itself.